Okay, 2003 multiple choice. I think we're doing 10 to 18. All right, number 10, the function f has the properties such that the function, its derivative, and its second derivative are all negative. Which of the following is the graph? If the function is negative, it's got to be below the x-axis. If the first derivative is negative, it has to be decreasing for all the values. And if the second derivative is negative, it's concave down. So I'm looking for below the x-axis, decreasing everywhere, and concave down, and the only place that that occurs. So it's below the x-axis, obviously. It is decreasing, and it's concave down. No more explanation needed for that. 11. This is an important one. U substitution. Using U substitution, they say U is equal to 2x plus 1. They want you to find the equivalent integral in terms of U. All right, so that means du is going to be equal to 2 dx, so du over 2 equals dx. So if I was going to rewrite this integral, it's going to be the integral from, 1/2 the integral. Now again, please make note, everything's in terms of u. So that means the upper and lower bounds need to be in terms of u. So this is going to be a u du. And now I just have to figure out what the upper and lower bounds are. So if u equals 2x plus 1, so the lower bound is going to be when I plug in x for 0, so 2 times 0 plus 1, so that'll be u is equal to 1. So my lower bound is 1, which means it can't be a, it could be b, can't be c, it could be d, and it can't be e. Now my upper bound, do the same thing, but plug in 2. So 2 times 2 plus 1, so that's 5. My upper bound is 5, my lower bound is 1, so lower is 1 and upper is 5. Oh, wait a minute, what the heck did I just do? I crossed out all the wrong ones. I thought the lower bound was 0. But anyhow, you see my mistake. The lower bound's 1. So I crossed out. It can't be that one, can't be that one. It's got to be C. And it can't be a half because there's not a 1/2 out in front. Okay, number 12, the rate of change of volume of water of a tank with respect to time. So dV dt, the rate of change of volume with respect to time, is directly proportional to the square root of volume. So that answer is going to be equal to a direct proportion is a constant times the square root of volume, so the square root of V. And that answer looks like it is E. Make sure I'm getting these correct. Yeah, 12 is E. All right, next, 13. The graph of a function is shown at which value of x is f continuous but not differentiable. And that one's pretty quick. It's continuous at A but not differentiable because it's a sharp turn. Let me make sure there's no others. At B, it's not continuous. At C, it's continuous and differentiable, and at D, it's not continuous. So answer is A. 13 is A. 14, they just want us to find the derivative. So if y equals x squared sine 2x, got to use a product rule, a little chain rule in there. So the first, the derivative of the second is cosine 2x times 2 plus the derivative of the first, which is 2x, and then leave the second one alone. Let's see how much simplification I have to do for this. So that's going to be a 2x squared cosine 2x plus 2x sine 2x. And I believe we can factor out a 2x. And that is going to leave me with an x cosine 2x plus sine 2x. Well, let's see where that one is. I believe that is E. Okay, moving right along. Let f be given by the function derivative. Find where it's decreasing. So it's decreasing where f prime is negative. Okay, so first thing I'm going to do is x squared minus 2 over x has to be less than 0. So if x was less than 0, so if x was less than 0, which means if x was negative, if I plugged a negative number into there, that would stay as positive, and that would also stay as positive because it would be a negative divided by a negative. So I know it cannot be decreasing for anything less than 0, any x value less than 0. So a would be gone, b would be gone, and c would be gone. Now I have to see if x is a positive number. So x squared minus 2 over x less than 0. I'll solve that. 2 over x. Multiply through by x. X cubed is less than 2. Take the cube root of both of those. So x has to be less than the cube root of 2. So it's got to be greater than 0, but it cannot be 0 because it'd be undefined there. And it's got to be less than, and by definition it's decreasing up to that point, but again, there's no other choice that includes that value as the upper bound. All right, if the line of 16, if the line tangent to the graph of the function f passes through those points, then f prime of 1. All right, you have to find the equation of the tangent line. So you have to find the slope first. So the slope is going to be y2 minus y1 over x2 minus x1, which is negative 9 over negative 3, which is 3. Point slope form doesn't matter which point you pick. So let's see, y minus 7 equals the slope, which is 3, and x minus 1. And we want to plug in f of 1 for that slope, for that tangent line equation. So y minus 7 equals 3 times 1 minus 1. So that's going to give me a 0. Move the 7 over, y equals 7. D. Last two here, let f be a function, graph concave down. So second derivative. All right, so f of x is equal to 2x e to the x. I'm going to do product rule. So f prime of x is 2x times e to the x. So I took the derivative of e to the x plus 2 times e to the x. After that, I'm going to take the second derivative of that, and looks like a product rule in there. So f double prime would be, again, of x, the first times the derivative of the second plus the derivative of the first times the second, and then plus e to the x. I think that looks okay. And there should be a 2 right there. Okay. So let's do a little simplification here. 2x e to the x plus, that's a 4 e to the x. Factor out a 2 e to the x. And that leaves me with x plus 2. This out here can never be, and set that equal to 0. That can never be equal to 0 out there because I have an e raised to a power. So the point I'm going to check is negative 2 in the second derivative. So I'll do f double prime of negative 3 and f double prime of negative 1. If I plug in negative 3, the easiest place to plug it in right here, that would give me a negative on the inside, and 2 times e to the negative third has got to be positive, so that's going to be negative, so it's concave down there. I know for this one quickly it's concave up, so it's positive. So it's everything less than negative 2, so that would be A. And then 18, the derivative g prime of a function is continuous, has exactly 2 zeros, and here they are. So that basically means in between there it's not bouncing back up and forth over the x-axis. Selected values of g prime are given, so this is a g prime chart. If the domain of g is a set of all real numbers, then g is decreasing. Well, g would be decreasing where g prime is negative. And g prime of negative is in there, so from negative 2 to 0. Excuse me, negative 2 to positive 2. So that would be A. Okay, there's up to 18.